Hi everyone. So we will be continuing redox reactions, and our discussion for today will be oxidation states. So what is oxidation state or oxidation number? The terms are used interchangeably, but it's the same thing, all right? So many redox reactions involve a complete transfer of electrons from one substance to another. These redox processes usually have ions as either reactants or products. And in some cases, the reactants and products are both ions, right? So using ions, we can tell whether something has been oxidized or reduced depending on what the charge looks like before the reaction and after the reaction, all right? However, some reactions which are regarded as redox reactions, in spite of the fact that they involve only molecules, they do not have a complete transfer of electrons from one substance to another. So sometimes you will have reactions that only have molecules, and you're not able to see the individual ions, and that's where things can get like a little bit difficult. And that's where we would need to use oxidation state or numbers. So what is oxidation state? It's the formal charge on an atom in a compound or an ion. All right, it's also defined as the number of charges an atom would have in a molecule or ion if electrons were transferred completely. So let's look at an example of this. So we have iron oxide reacting with aluminum to form pure iron and aluminum oxide. So each one of these atoms or elements are given an oxidation state below. So here iron has an oxidation state of +3, oxygen has a state of -2, aluminum 0, iron 0, aluminum here is +3, and oxygen here is -2, right? Now, before, when we were looking at redox reactions, I would have asked you to look at the changes in the individual atoms, right? So here we can see the change in iron, right? It went from Fe3 plus to Fe, right? Which indicated that it would have gained 3 electrons. But now we can look at the oxidation number or the oxidation states. So look at the change in oxidation state here. It went from +3 to 0, right? So in this case, the oxidation state decreased or it reduced, right? So reduction is the decrease in oxidation states. So here we can say that iron was reduced, and it's also regarded as the oxidizing agent, right? If you look at the oxidation state of oxygen, you'll see that there's no change, right? And now for aluminum, the change, it went from 0 to +3. So there was an increase in oxidation number or oxidation state, right? So oxidation is the increase in oxidation state. So once you see this change, this would signify that aluminum was oxidized. Once it has been oxidized, it will be regarded as the reducing agent, all right? So here are the half reactions, just to show you that iron was reduced and aluminum was oxidized. So using oxidation numbers, it's possible to decide whether redox has occurred in the processes involving either transfer or reshaping of electrons. So you might be wondering, how did we come up with these numbers? All right, so firstly, let's look at the zeros, all right? So these are one of the rules that you must learn. The first one is the oxidation numbers of the atoms in uncombined elements are given an oxidation state of 0. So here we can see aluminum and iron are uncombined elements. They are in their free state or in their free elemental form, right? Once they are in that free state, we give it an oxidation number of 0, right? However, for these, right, for simple ions, the oxidation number is simply the charge of the ions. So we have an oxidation state of +3. In this case, iron has a charge of 3+, right? For oxygen, oxygen has a charge of -2, so we give it an oxidation number of -2. Aluminum has a charge of +3+, and we will give it an oxidation number of +3. So I'm sure you're seeing a pattern here, right? Now, using that same pattern, we can predict oxidation states. So generally, the oxidation state for most common elements can be determined from their group number on the periodic table. So this is basically the shape of the periodic table, right? Group 1, Group 2, Group 3 elements, they would have a charge of +1, +2, +3, right? Going on to Group 4, you can have an oxidation state of either + or -4, right? These will have oxidation numbers of -3, -2, -1, and Group 8 will have an oxidation number of 0 because it's mostly uncombined elements. All right, now this big space here, this is where we would usually have our transition elements, and that's why they are put separate from the groups. It's really because of their variable oxidation states or their variable charges. For example, we know that iron can have an oxidation state of +2 and +3. We know copper can have an oxidation state of +1 or +2, right? So transition elements are not included as they tend to exhibit a variety of oxidation states. Now here are some rules that you need to learn. All right, we just went through rule 1. Uncombined elements have an oxidation number of 0. For example, these, all right, they can also include diatomic molecules such as chlorine and oxygen, right? Another rule is that the oxidation numbers of elements in a compound add up to 0. For example, in sodium chloride, sodium has an oxidation number of +1 because we know it's a group 1 element, right? Chlorine, we know chlorine normally has a charge of -1. So the charge on chlorine will be, the oxidation state of chlorine will be -1, right? So if we add up these two things, we get 0. Okay, so the oxidation number of a monoatomic ion is equal to the charge on the ion, right? So say for example, we have zinc with a 2+ charge, the oxidation number will be +2, right? Same thing with chlorine, oxidation number is -1. Now in a polyatomic ion such as carbonate, the sum of the individual oxidation numbers of the elements adds up to the charge on the ion, all right? So carbonate, we're going to add up the individual oxidation states, and it's going to be equal to the charge, which is -2, okay? So carbon will have an oxidation number of +4, and oxygen will have an oxidation number of -2. Now we have 3 oxygens here, so we have to multiply it by 3, right? So +4 plus 3 by -2 is going to be equal to -2, and as you see, it adds up, right, to the charge. Equal to The next rule is several elements have invariable oxidation numbers in their common compounds. So we did this already. Group 1 metals will have an oxidation number of +1. Group 2 metals +2. Group 3 will be +3, right? Hydrogen is usually +1, except in metal hydrides. That's where it's combined with a metal. It's -1. Fluorine is usually -1. Chlorine, bromine, and iodine are usually -1, except in compounds with oxygen and fluorine. Oxygen is usually -2, except in peroxides where it's -1, and in compounds with fluorine, right? So this is very important information. You need to learn this, all right? And you will have to apply each and every one of these rules when you are doing your calculations. So let's do one worked example now. Calculate the oxidation number of the underlined element. Right, so we have two compounds here, and in both cases the underlined element is chromium. Right? So we know potassium is a group 1 element, so it will have an oxidation number of +1, right? We don't know the oxidation number of chromium, so we'll give it, we'll call it X, right? And oxygen has an oxidation number of -2, and here we have 4, right? So this is a compound that is neutral, there's no charge, so the sum of the oxidation numbers will be equal to 0, right? So 2 potassium plus X plus 4 oxygens will add up to 0. When you find for X, you'll get +6. Right? Remember to always put that plus sign. Even though it's positive, we need the plus. Right? Going on to this one now, we have 2 potassium, 2 by +1. We have 2 chromium, 2X, and we have 7 oxygens, 7 by -2. Right? Now this is an neutral compound. It's uncharged. So the sum of the oxidation numbers will be equal to 0, right? When we add them up, we find for X, we see the oxidation number of chromium is +6. So here are some questions I would like you all to work on. All right, make sure you do your calculations in your notebook. You can go to the original PowerPoint file I'll be uploading, so you can take your time with them. Okay? I would also like you all to do these summary questions. These are questions that are in the Antindale textbook. What I would like for you all to do is to volunteer to do these questions for me. Message me the answers and I will post it up on the group. Okay? So I want to see how you all are working. I'm not just providing answers, so I want you all to volunteer to do some of these questions for me. And you know how it goes in class. If you don't volunteer, I will volunteer you. All right? Remember to continue making your notes in your chemistry notebook, and all these calculations, make sure you do them in your notebooks. And also these questions here, I have the answers. There's the answers posted online. All right, so if you didn't get them correct, you can see where you went wrong. Okay? And that's it for today. Our next video will be tests on oxidizing and reducing agents. All right, so make sure you go over the video again, go through your notes, and look out for the next video. Okay, so take care. Bye for now.